Okay, Math 30-2, Exponential and Logarithmic Functions, lesson number 6, practice test. Again, these videos are for study purposes only. I tried my best to minimize my mistakes, but it will happen. I try to show and explain most of my steps. These videos might be long, but hopefully they will be helpful. Alright, let's get started. Okay, here's a partial graph of y is equal to a to the power of x. If we add a 1/3 to the power of x, what the 1/3 is going to do is going to shrink the graph, but everything else will stay the same. So there is going to be a horizontal asymptote at y is equal to 0. Therefore, the horizontal asymptote will stay. And my y-intercept, before my y-intercept is at 1. Now because of this 1/3, my y-intercept will be equal to 1/3. And the shape of the graph does not change, it just got compressed down. So the answer is B, and you can see that the y-intercept is approximately 1/3. Okay, the range of this function. So 3 to the power of x looks like this, but because there is a negative sign, it has been reflected across the x-axis. So it looks something like this. The y-intercept is equal to -1. And there is also a horizontal asymptote, so y can only be smaller than 0. So y is less than 0. Y is an element of the reals. That will be the answer. What's going on? Okay. 3. The graph best represents this when a is less than 0. When a is less than 0, that just means the graph are on the bottom two, or in quadrant 3 and 4. So either like this or like this. And b is, so usually when b is less between 0 and 1, the graph is an exponential decay. And because a is less than 0, it has been flipped across the x-axis. Your new graph will look like this. So it can look like that. D. Keep going. What is the domain of g of x of a log base 3 of x? So the domain of all log functions, doesn't matter which way they turns, is so this is the first one, and then this is a possible second one. So is x must be greater than 0, and x is a real number. So 4 is going to be A. 5. The equation of asymptote of the graph y equal to 2 log x. So this is log base 10. My asymptote for log functions will always be at x is equal to 0. That is a vertical line. 5 is C. 6. Consider these graphs. Okay, the partial graphs of the exponential function are shown, but not in the order above. These graphs are drawn like this. Okay, so they just want us to order them. So what is the difference between them? Well, obviously the y-intercepts are not the same, and this one is an exponential decay. When you have an exponential decay, that means your b value is between 0 and 1. Which b value is between 0 and 1? G is between 0 and 1, so diagram 2 must be G. Okay, once we used up G, now your A value, so this 1/2, 3, and 2 will determine what your x-intercept is. So the x-intercept is 1/2, first, the y-intercept. The y-intercept is equal to 1/2, so this must be F. This y-intercept seems to be smaller than that, so this y-intercept must be 2, this one must be 3, so this one is H, this one is K. Okay, y is equal to f of x is 4, y is equal to g of x is 2, y is equal to h of x is 1, and then y is equal to k of x is equal to 3. Okay, which one of these graphs does not pass through the point 1, 10? Okay, so that means when x is equal to 1, y is equal to 10. So 10 to the power of 1 is always equal to 10. 5 to the power of 1 is 5 times 2 is 10, so it checks out. 6 to the power of 1 is 6, times 4 is 24, it doesn't check out. 5 times 2 to the power of 1 is 5 times 2 is 10, it checks out. So the only one that doesn't check out is C, so 6 is C. 7. The graph that best represents A times or y to A log B x, where A is greater than 0 and B is between 0 and 1 is. So when A is greater than 0, that just means there's no reflection. And then when B is between 0 and 1, that means it is a exponential decay graph that got flipped across the x equal to y axis. So the graph is going to look like this. Alternatively, just pick a number b that fits into this definition, and pick a number a that fits into this definition, and then go for it. So this one is exponential growth. This one is exponential decay. And then this is just your logarithmic graph where b is greater than 1. And then this is our logarithmic graph when b is between 0 and 1. One thing to note that if a is less than 0, then the graph will get flipped across the x-axis, so it could look like it's reversed. So 7 is going to be D. The graph that best represents a times b to the power of x when a is greater than 0, so that means no reflection. And then b is between 0 and 1, that means it is a exponential decay. So no reflection and exponential decay is going to be graph 2. So 8 is going to be B. Okay, consider all the exponential functions in the form of this. Here are the two graphs. Okay, if a is greater than 0 in graph 1, then what value of b in graph 1 must satisfy one of these conditions. So if it is an exponential growth means b is greater than 1, so 9 is going to be D. 10, if the function has a is less than 0 and b is greater than 1, so when b is greater than 1, it's going to be an exponential growth. But since a is less than 0, that means it's going to get flipped across the x-axis. So it's going to look something like this. So therefore, it decreases from quadrant 3, where this is 3, into quadrant 4. So it looks like 10 is A. Graph 2 is a reflection of graph 1 in the y-axis, correct? Student told that in graph 1, a is equal to 2, so y is equal to a to the a times b to the power of x, so y is equal to 2 times 3 to the power of x. They're asked to comment a and b for graph 2, which of the responses would provide graph 2. So I don't think it is explicitly stated in this unit, but if you want to produce graph 2, then you see they have the same x-intercept, so that means the a value does not change, so that means a is still equal to 2. So now your b value cannot be less than 0, so the only option is C. Alternatively, you can graph it and you'll see that this will produce the exact same graph that is opposite to graph 1. So 11 is C. Keep going. Consider all the logarithmic functions in the form of a log base b of x. The graph of two such functions are shown. If a is greater than 0 in graph 2, then what is the value of b? So if a is greater than 0, that means there is no reflection across the across the x-axis. That means the original, if I take a look at the exponential function, it looks like this, as it has been reflected across the x equal to y-axis. And we know this exponential function is when b is between 0 and 1. So 12 is going to be b. Or again, you can just plug in some numbers, see what it looks like. Okay, if in the function f of x, the value of a and b are both positive, when which of the following value of x is a function f of x not defined? So when a and b are both positive, we know that b cannot equal to 0. So a can be whatever positive number you want, but b cannot equal to 0. Sorry, b cannot equal to 1, because if b is equal to 1, the question just kind of loses meaning. So f of what is undefined? So what can my input be, right? So I know the domain of any logarithmic function is x must be greater than 0. X is a real number. Since a and b are both positive, that means it's greater than 0. A and b cannot be the answer. C 1/2 is greater than 0. It cannot be the answer. So the answer is going to be D, because 0 is not greater than 0. It does not fit into the domain. 14. Graph 2 is a reflection of graph 1 in the x-axis. Students are told in graph 1, a is equal to 5, b is equal to 2. So y is equal to 5 log 5 log base 2 of x. They ask to comment student a and b graph from 2. Okay, so now they want to know what graph this. Okay, so they want to find what a and b are for graph 2. So now you just take a look at, so you can just graph this out, see what it looks like, and which one of it cannot be true. So a is equal to 5. You know what, let's just graph it. 5 log base 2 of x. Sometimes okay, so 5 log base 2 of x. Student 1 seems to be fine. Student 2, it doesn't. It feels kind of weird. Student 3 is also kind of weird, but that's just me. Let's graph it, see what it looks like. So 5 log base 2 of x. Okay, y is equal to 5 log base 2 of x. Okay, I will go and what is the other one? Negative 5 log 2 of x. Okay, so negative 5 log base 2 of x. Okay, so just go to the table. You should see that the x and y value, the y1 and y2 value should be complete opposite of each other, which they are. So good. So that means student 1 is correct. Student 2, a is equal to 5, b is equal to 1/2. Or I'll just do the c first. Let's take a look at the table. Okay, so c is the same as, it's not flipped, it's the same as a, so c cannot be right. In our graph 2, we just go back to graph 1. Okay, last one, b, which is 5 and negative 2, or it's 5 and, sorry, and a half. Let's take a look at the table. Okay, it looks like they're also correct because everything is flipped. So student 2 is also correct. So 14, only student 3 is not correct, which is C. So what happened with student 3 is so if A becomes negative or B becomes a reciprocal, it will flip the graph across the x-axis. But because student 3 had both of these things, A is both negative and B is reciprocal of the graph, it flipped the graph once and then twice, so it went back to the original. Okay, to the nearest tens, the x-intercept of the graph 8 times log base 5 of x is. I thought the x-intercept is always equal to 1, no matter what. Let's take a look. How is it? 8 log base 5 of x. Okay, so when x is equal to 1, y is equal to 0. So that means my x-intercept is equal to 1. But they want to the nearest tenth, so the answer is going to be 1.0. A student graphs the following table of data that measure relationships that are in the exponential form. Okay, so exponential regression, they want to calculate what B is. Okay, so let's go to stat edit. Uh, 2, 5, 7, 11, 14, 2. 2, 5, 7, 11, 14. 5, 7, 7, oops. 7, 11, 14. Okay, what is the other one? Let's take a look. 0.9, 12, 69, 2280, and 31500. Okay, so now stat calc. So let's just go y is equal to, turn on plot 1, see what it looks like. Zoom 9 to go to zoom stat. Okay, it looks like an exponential regression. Or sorry, yeah, exponential function. Stat calc. Exponential exp reg, which is 0. Okay. X1 list 1, X2 y list 2, no frequency list. Store the equation into y1, then calculate. Okay, so B is equal to 2.39. So they want us to round to the nearest tenth, so 2.39 will round to 2.4. Now, if you have a non-TI-84 calculator, you must enter the exponential regression exactly how you see it, line 1, line 2, sorry, list 1, list 2, y1, in order to graph everything. So how do I enter that? So I just go with what I have done before. With stat calc, then press 0 for exponential log or exponential regression. Then list 1 is second 1, comma, list 2 is second 2, comma, y1 is under variables, so that you don't have to type into y1. So under variables, press right for the y variables, go to function, and then go to y1. Okay, then it will do the exact same thing as your little wizard did for you. Okay, 15. In the diagram, P is a partial graph of y to log base of x. The point Q could be the graph of. So the graph got a little bit more compressed. So this is log base 10 of x, right? So if I want to compress a graph a little bit more flatter, then I have to increase the base value, right? Because if you look at the base value here, 2, 5, this is log base e, which is your log base 2.718, right? So all three of these are less than 10. So the only one that is bigger than 10 is 100. So the bigger your base is, the flatter and more compressed your graph will be. So 15 will be D. Okay, use the following information to answer next three questions. Blah blah blah. Run from calculate one to pick. 10 kilometers on the first day. Increase distance gradually for each subsequent day. Chart shows how far Shannon will run in each of the days. Okay, so increase her distance gradually. This looks like an exponential, which is an exponential, a times b to the power of d, using technology. Okay, so again, regression 1, 2, 3, 4. Stat, edit, clear these lists. Clear these lists. Okay, so let's go 1, 2, 3, 4, 10.25, 10.51, and then 10.77. 10.77. Okay, now stat, calc. Well, I'm just gonna reuse my exponential regression again, just so I don't have to do it, and I'm gonna zoom stat to get to it. Okay, so it doesn't look like a really good exponential regression, but we have to change our window settings. Like change our x max to like maybe I don't know, 30 days. X minimum is 0. Y minimum, let's change it to 0, and then Y maximum, let's change it to 50. Okay, so it does look like it is an exponential regression. So what is the value of B? Oh, I forgot my value of B. Good thing I can see it right here. 1.025. Now, using Shannon's model, the first day that she will run more than 15 kilometers is. So I know my y value is equal to 15, and I want to find the intersect of the graph. Second calc, 5 for intersect. Enter. So on day 17.37, so on the 18th day, because we always round up no matter what, Shannon will run more than 15 kilometers. Okay, so if you trace it, 17. Is this trace? No, it is not trace. I said 18 days, right? I want to trace a blue one. So on the 18th day, Shannon will run. So if you see 17.7 is already 15, but we must look at the first whole day. So the 18th day, Shannon will run more than 15 kilometers. So 17 is going to be C. For using Shannon's model, to the distance to the nearest tenth of a kilometer, she will run on the 30th day. So I'm just gonna go trace. So I know my x is equal to 30, or my my d is equal to 30. So trace 30, enter. So 20.5 kilometers. Yeah, 20.5 kilometers. Okay, a light source with intensity I0 is reduced to an intensity I after passing through x meters of fog according to the formula I is equal to I0 e to the power of negative 0.15x, where e is approximately 2.72. At what distance to the nearest tenth of a meter will the intensity be reduced to 1/2? So you can say the initial intensity is 100, and then once it reduced to half is 50. Or you can say the initial intensity is 2, once it reduced to half is 1. What I'm going to say is the initial intensity is 1 because it is 100%. Then after it got reduced by half, it should be equal to 0.5. So I'll just type this into my graph. Okay, I don't need plot 1 anymore, so make sure I disable it. So now I'm going to say 1 times e to the power of negative 0.15x is equal to 0.5. So what's my window look like? Since my y max is biggest partial value is 1 because it will be decreasing, so I'll just say y max equal 1. See what it looks like. Okay, I want to find that intersect. Second calc, 5 for intersect. Enter. My intersect is 4.62. Let's see how they want us to round it. 4.62 meters, I guess. Okay, use the following information to answer the number of years why it takes to our investment of $1,000 to increase in value by X dollars can be modeled by a logarithmic function in the form of this. This table shows the value of Scott's investment after a period of 10 years, or over the period of 10 years. Using above model, the number of years it takes complete an investment with double in value is. Okay, so put in this X or list 1, list 2, type it in, stat edit. Okay. Two for oops. All right, and then 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay, zoom stat. Oh, oops, my Y1, my stat is not, my plot 1 is not enabled. Zoom stat 9. Okay, looks like it is an logarithmic growth. Okay, now stat calc. This time we're going to do 9 long regression, list 1, list 2, store the equation into Y1, calculate. Okay, so here's my stuff, and then I want to graph it. So if my investment doubles, that means my X value will be equal to 2,000. So I want my X max to be 2,000. Yeah, 2,000. And my Y max, I probably want it to be around 15. So let's say 20. Okay, so my input will be 1,000. Or sorry, double in value. So instead of 1,000, my X will be 2,000. And I'll find what my Y is. So trace 1,000. Oops, trace 1,000. Sorry, 2,000 is 17.68 years. 17.68 years. So you always have to round up, which is equal to 18 years. 19 is B. After 15 years, so that means my Y is equal to 15. Okay, and then find the intersect right here. Second calc, 5 for intersect, enter. There is only one intersect, I don't have to guess. It is about $1,800.37. $1,800.37. The rate of radioactive decay is often described using a half-life time it takes for the amount of radioactivity to decay to half its initial amount. The radioactive cobalt-60 is often used in radiotherapy in hospitals. The half-life of cobalt-60 is 5.2 years. The decay of cobalt-60 can be represented by this formula. So the initial amount is 150 grams. So that means A naught is equal to 150. To the nearest tens, how many years will it take to reduce to 30 grams? Okay, so Y is equal to, we can disable plot 1. So 150 grams is to start all off, and then times 0.5 to the power of x divided by 5 over 2. X divided by 5.2. Okay, so let's think about what my window should be. Because this is an exponential decay, the biggest my Y value can be is 150, and the smallest my Y can be is 0, which it will never reach. Then how many years would it take to go to 30 grams? Well, probably I would say around 20 to 30 years. Let's just do 30 to be safe. Okay, and not 20, 30, maybe 15 years. We'll see. So I wanted to have 30 grams. So graph it. I want to find where that intersect is. Second calc, 5 for intersect. Enter. 12.07 years. So that means y is equal to 30. So I get x is equal to 12.07 years. And I have to round, which is equal to 12.1 years. Okay, so now instead of 150, I have a 250 gram sample. So 250 gram sample after 24 years. So I don't need this anymore. I want to see how much it has after 24 years. So trace 24, enter, 10.19 grams. So A naught is equal to 250. 24 years, so x is equal to 24. What is my y value? It is equal to 10.199. 10.199. Once you round it, you get 10.2 years to get to the nearest tenth of a gram. 10.2 years. Okay, written response. The population of a rural community has been decreasing since the year 2007. The partially completed table below us shows the population, the decrease in population, and the percent decrease in population from 2007 to 2012. Okay, complete this table. Year 1, so there is a decrease. So I divide the decrease by the previous year's population. Decrease divided by previous population. Okay, 785 divided by 23320. Okay, so 785 divided by 23320. 3.36%. 3.36%. 3.37%. Okay, so next one, so we divide this by this. Now we divide this by this. Now we divide this by this. 795 divided by 22535. 3.53. 795 divided by 22535. Okay. This one is 760 divided by 20980. 760 divided by 2090. 3.62%. And the last one, 20980 divided by 730 divided by 20980. 3.48%. 3.48%. Calculate the average of the percent decreases, round to the nearest tenth of percent. So we're gonna add all these up. 3.64. 3. Okay, so the whole thing divided by 5, you get 3.528%. 3.528%. rounded to the nearest thing, we get 3.5%. Okay, the relation between your year number and the population can be written as Pn is equal to a times b to the power of n. Use exponential regression to determine the equation. Round a to the nearest 100 and b to the nearest thousandths. Okay, so we are going to type all of these in. Okay, so 0, 1, 2, 3, 4, 5. Stat edit. 0, 1, 2, 3, 4, 5. 2, 4, 2, 0, 0. Okay, stat calc. We want to do power or exponential regression because this is exponential decay. We'll store it into y1 just to be safe. And I have 24139 nearest 100, 24100 times 0.966, 0.966 to the power of x. Okay, that is the exponential regression. Okay, so how is 0.966 relates to 3.5%? So usually you have 100% of the population, and then you subtract the decrease, which is 3.53, and then I'll get get 96.47, 96.47, which rounds to 96.5, which is very, very close to what we have over here. Or sorry, is equal to 0.965, which is what we have here. Okay, use the following information to solve the remaining problem. A neighboring town also has been decreasing population since the year 2007. Blah, blah, blah. What percent rate of population decreasing from year to year? So this is 0.93. 1 minus 0.93. So 0.93 is what population remaining, right? So we get 0.07 of the population is leaving, which means 7% of it is leaving. Use the above to estimate the population of town to the nearest hundredth in 2017. So you know what? We'll just graph this because I think it's the easiest. 18400. Okay, 18400 times 0.93 to the power of x. Okay, so I will start off at 18400, so that will be my y maximum. 18400, and let's say we run it for a period of 30 years. Okay, so 2017, that means n is equal to 10. So trace 10, enter. 8905. Okay, so 8 to the nearest 100, 8900 people. Determine at which year the population will be first to expect to fall below 6,000. So y is equal to 6,000. Let's do the intersect. Oops. Enter. So at 15.44 years, it will be 6,000. So at 16 years, so when n is equal to 16, it will be less than 6,000. But I don't care about n, right? I care about 2007. Uh, no, so the following is gradual, right? So it is 15.4 years, right? So 2007 plus 15.44 is equal to. So I will say about in 2022 April, it will fall below 6,000. So in the year 2022, it will fall below 6,000. Okay, that's it for the exponential and logarithmic function. Hopefully you learned something. Goodbye.